NASA's James Webb Space Telescope may have detected something impossible, a star made of a matter we can't even see. We can only observe the effects caused by the star and then predict its existence in the universe. Well, I'm talking about dark matter star. Dark matter is one of the biggest unsolved mysteries in physics. To understand how something so impossible might exist, we need to go back 13.8 billion years to the very beginning, the Big Bang. Right after Big Bang, positively charged hydrogen ions began forming everywhere. But the universe was expanding and cooling at an extreme rate. This led to a turning point where, due to the expansion, the total energy of the universe dropped so low that the hydrogen atoms stopped fusion altogether. No fusion means no stars. So, according to physics, the early universe should have remained dark forever. But clearly, something forced star formation to begin. Something powerful. And something that did not behave like ordinary matter. This is where scientists found a gap in the mathematics. The numbers didn't match reality, so they proposed the existence of a strange new form of matter, something invisible, interacting only through gravity. They called it dark matter. By 1980s, some particle physicists theorized dark matter, like normal matter, was formed at the time of Big Bang. The only difference was that it was made up of a different class of subatomic particles called WIMPs, that is, weakly interacting massive particles. When enough WIMP particles gathered together, they started attracting normal matter gravitationally. These WIMP particles attracted the hydrogen atoms, brought them together, which increased their energy and thus kick-started fusion. And because star formation may have begun due to dark matter, some scientists suggested the first stars were made up of dark matter. Many considered this idea absurd until a discovery changed everything. Researchers from Michigan State University and the University of California were investigating how Sagittarius A, the supermassive black hole at the center of the Milky Way, could have existed just 200 million years after the Big Bang. What they found was contradicting. You see, according to the Big Bang model, the first stars shouldn't have formed until 100 to 400 million years after the Big Bang. And for a black hole to grow supermassive, it typically needs close to 1 billion years. So something isn't adding up. Their answer was dark matter. To verify this, researchers simulated early universe in a supercomputer, and what they observed was insane. They observed that the dark matter particles first formed a donut-shaped disk, and then as the disk evolved, it transformed into a supermassive black hole in just 270 million years. Now, if dark matter particles can form black holes, then why can't these particles form a star? To make it more clear, let's understand the formation of a normal star. Star formation begins within the nebula. There is a constant tug of war between pressure and gravity. Gravity attracts the hydrogen molecules towards the center, and the pressure between the gas molecules pushes them outside. More and more molecules are attracted towards the center, so the center becomes dense, and the particles there start to get heat up because more density, more pressure results in more temperature, and a protostar is born. This protostar continues to become hotter and denser for the next 500,000 years, and its core reaches up to 15 million degrees. This temperature kickstarts fusion, and a star is formed. Exactly the same thing happens during formation of dark matter stars. The only difference being, instead of the gravity of hydrogen molecules, the gravity of dark matter clouds attract hydrogen atoms, which is called dark matter capture. Then these particles give those normal atoms the energy they need to kickstart nuclear fusion. So unlike normal stars, nuclear fusion in dark matter stars start due to dark matter. But as I said before, these were only theories and simulations whose first experimental evidence was found in a 13.6 billion-year-old galaxy. Under the Advanced Deep Extragalactic Survey, James Webb Space Telescope discovered 3 galaxies whose age was between 13.4 to 13.6 billion years, meaning they were formed only after 200 million years after the Big Bang, which is contradictory in itself. As for a galaxy to form and mature, it takes about 1 billion years. So physicists assume that these are not galaxies, but stars made of dark matter. Since no scientist has ever directly observed a dark matter star, physicists created a test model using simulation software. They entered the theoretical properties of a dark matter star into the program, and the software generated a predicted spectrum showing how such a star should interact with light. To verify this, scientists tried to compare the simulated spectrum with the 3 mysterious objects discovered by JWST. But there was a major problem. Normally, JWST provides spectrographic data along with images, but in this case, there were only images, no spectrographic data at all. So researchers improvised. They passed the images through different color filters and extracted RGB intensity peaks to reconstruct an approximate spectrum. That reconstructed spectrum was then compared with the one generated by the simulation, and a graph was plotted. You see these black dots? These are the real data points collected by JWST, and this blue curve is the simulated model generated by the software. And as you can clearly see, they match, which suggests that the objects discovered by JWST might actually be dark matter stars. But does that solve the mystery of dark matter? Well, scientists found flaws in this whole method. They were comparing real data with a simulation of something we've never observed in the real world. Secondly, the spectral data used here wasn't real. It was artificially reconstructed, meaning critical information was lost. And finally, the magnification limit of JWST. These objects are 10 million times smaller than what JWST can reliably resolve. So calling them stars instead of galaxies might be scientifically inaccurate. So the mystery remains. If dark matter stars actually exist, JWST has already found something even more mysterious, and that's in the next video. Stay tuned.